Okay, in this video we're going to go over our special triangles, and we're going to start here with the 45, 45, 90 right triangle. And we're going to build this from scratch. So to build a 45, 45, 90 right triangle, what I'm going to do is start with a construction of a square where all the sides are equal and all the angles are 90 degrees. All right, so let's just choose a size arbitrarily, 8 centimeters by 8 centimeters. Okay? Now what we're going to do first is draw in the diagonal. Now the diagonal will bisect the 90-degree angle, and 90 degrees divided by 2 is 45 degrees. So right away I know that angle is 45 degrees, this angle is 45 degrees, and that's 90 degrees. And so here we have a 45, 45, 90 right triangle constructed from scratch. We know this side measures 8 centimeters, this side measures 8 centimeters, but we don't know what the hypotenuse is. So we're going to have to figure that out. Now to do that, what we'll do is just run the Pythagorean theorem. So let's call that D for diagonal, and we can say the hypotenuse squared is equal to leg squared plus leg squared. Right? So in other words, d squared equals 64 plus 64, which is 128. And then extracting the square root here, taking the square root of both sides, don't forget the plus or minus, we'll choose the positive value because this is geometry. And we can say then d equals the square root of 128. Now 128 is 64 times 2, yeah, 64 times 2, and the square root of 64 is 8. So d is 8 square root of 2 centimeters. All right, and I can write that in here, 8 square root of 2. So now I know all sides of this right triangle. Okay. The goal is to find all 6 trig ratios of 45 degrees. Now, let's look at this 45 degrees, and the side opposite is 8. So we can say sine of 45 degrees is opposite over hypotenuse. Now in this case it's 8 centimeters. So 8 centimeters over 8 root 2 centimeters. Of course this is a length as well. The hypotenuse is 8 root 2. Notice two things. Number one, the units cancel. Okay, so trig ratios are actually unitless. And also here, this factor of 8 cancels. And that leaves me with a 1 on top in the numerator. And we have 1 over root 2. So 1 over root 2 is the trig ratio that's associated with sine of 45 degrees. Now, since this is one of the special angles that we're supposed to memorize, typically they want us to rationalize that, but rationalizing is optional. And we get square root of 2 over 2. So you might see sometimes 1 over square root of 2, and sometimes you might see square root of 2 over 2. Those are the same. You do that on a calculator. Okay, let's move on to cosine. Cosine is defined to be the side adjacent over hypotenuse. So the adjacent side here is 8, so we have 8 centimeters. Again, the hypotenuse is 8 root 2 centimeters. The centimeters cancel, and I'm left with, again, 1 over square root of 2 after the 8's cancel as well. 1 over square root of 2 is actually equivalent to square root of 2 over 2. Right? Those are actually the same. That's kind of neat. So sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2. Those ratios are the same. Let's look at tangent. Tangent of 45 degrees. Tangent is defined to be opposite over adjacent. So in this case, 8 centimeters over 8 centimeters, which is, after I cancel, I get 1. Now at some point I'm going to stop putting the units because the units will always cancel when you do trig ratios. And there we have it. Okay, so just really quick, let's check these on a calculator. Now when you use your calculator, what we're going to do is calculate sine of 45 degrees. So I have a button here, sine, push that. And then when I type in 45 degrees, I better make sure I'm in degree mode because that is a degree measure. If you're not in degree mode, hit your mode button and make sure you move the degree from radian, gradients, make sure it's on degrees. All right, so I am in degree mode. To get out of there, I'll have to hit Shift and then quit. And then hit Enter. So notice my calculator gives exact answers, root 2 over 2. If I actually wanted the approximate answer, I would go down here and push my approximate button, which is this button right here, just above the equal, or the Enter button. And so root 2 over 2 is the same as 0.7071. Okay, let's check cosine of 45 degrees. And we get root 2 over 2. That looks good. Let's check tangent of 45 degrees. And we get 1. Now, we did it on the calculator just as a check, but actually we're supposed to memorize these. Okay, so once we have that, we can find the other three. The other three ratios are just reciprocals. So we'll first look at cosecant of 45 degrees is the reciprocal of sine. And since these two ratios are the same, I'm going to choose 1 over root 2, and I'll reciprocate that, and I'll get root 2. And so that's cosecant of 45. Secant of 45 degrees is the reciprocal of cosine. And again, I'll choose the 1 over root 2, reciprocate that, I get root 2. And then tangent of 45 degrees is the reciprocal, cotangent of 45 degrees is the reciprocal of tangent. And tangent is 1, 1 over 1 is just 1 again. All right, so there's the 6 trig ratios that we're supposed to memorize for 45 degrees. All right, so next let's move on to the 30, 60, 90 right triangle. And again, we'll do this from scratch. To construct the 30, 60, 90, we start with an equilateral triangle. That's a triangle where all the sides have the same length. And again, I'll arbitrarily choose a length. I'll just say each side is measuring 8 centimeters. Now this is a little different for a square. We knew all the angles were 90, but in this case, we need to figure out what the angles of an equilateral triangle have to be. Well, definitely it's equilateral, so they're all going to measure the same, right? They're all going to have the same angle. And we know all the angles of a triangle add up to 180 degrees. So we can write theta plus theta plus theta adds up to 180 degrees, right? In other words, 3 theta equals 180 degrees. And then dividing by 3, we get theta equals 60 degrees. So that means each angle in an equilateral triangle, no matter what, is always going to be 60 degrees. All right. So I know this is 60, this is 60, and the top angle is 60. Now we're actually after a 30, 60, 90 right triangle. So what I'm going to do next is from the peak, I'm going to drop an altitude. When I construct an altitude, that'll bisect this angle, which we know is 60 degrees at the top there, and then half of 60 degrees is 30 degrees. Okay? Dropping an altitude like that is how we're going to construct our 30, 60, 90 right triangle here, highlighted in green. Awesome, from scratch. Now what we're going to do is find the 6 trig ratios for 30 degrees and 60 degrees. And I'm not going to use the units because the units are going to cancel. So I'm just going to have at it. And we'll start with, I can't find all 6 trig ratios until I know all the sides. So let's first get all the sides. When I drop an altitude, the base here is going to get bisected. And so the bottom of this triangle here is measuring 4 centimeters. And then we need to figure out the height. This height here can be calculated using the Pythagorean theorem. Okay, so we could say leg squared, which is the height, plus 4 squared. Leg squared plus leg squared equals hypotenuse squared, right? So 8 squared. So I can say 8 squared plus 16 equals 64. Subtracting 16, that's 48. 64 minus 16 is 48. So 8 squared equals 48. Then take the square root. It's actually plus or minus, but we'll take the positive value here. We're doing geometry. And so we get the square root of 48. Now 48 is 16 times 3. Yeah. And the square root of 16 is 4. So the height here is going to be 4 square root of 3 centimeters. And I'll erase that h and put that in there, right? 4 square root of 3. Okay, so now we have all of the lengths of all the sides of this 30, 60, 90 right triangle. So now we can actually calculate all 6 trig ratios. Let's start with the 30 degrees. Okay, so I'm looking at 30 degrees. I'll look at the side opposite, which is 4 centimeters. All right, so sine of 30 degrees is opposite over hypotenuse. So 4 over hypotenuse is 8. And when I reduce, I get 1/2. Again, I'm not using the units because I know they're going to cancel. Cosine of 30 degrees is defined to be side adjacent, which in this case is 4 root 3. And so I get 4 root 3 over 8. I have some cancellation. 4 goes into 8 twice, leaving me with cosine of 30 as square root of 3 over 2. And then tangent of 30 is defined. Tangent is defined as opposite over adjacent. So in this case, 4 over 4 root 3. And then the 4's cancel, and I'm left with 1 over root 3, which rationalizes to root 3 over 3. Those are the same. Okay, so let's check those on a calculator. We can actually verify that. All right, let me clear that out. I am in degree mode, so I can say sine of 30 and see that the answer is 1/2. Cosine of 30, enter, and I can see that I get exact answers, square root of 3 over 2. That's why I like this calculator. It gives exact answers. If you don't have a calculator that gives exact answers, you might see 0.8660, and that's fine. You definitely are at an advantage if your calculator can give exact answers. All right, so tangent of 30 is square root of 3 over 3, and that's what we have. Awesome. From scratch, we developed that. Now, certainly the other 3 trig ratios are just the reciprocal. So we could say cosecant of 30 degrees is going to be the reciprocal of sine. So the reciprocal of 1/2 is 2. Secant of 30 degrees is going to be the reciprocal of cosine. And so the reciprocal of that would be 2 over root 3. And I'm going to leave that unrationalized. That's okay. And then cotangent of 30 degrees is going to be reciprocal of tangent. So I'll choose this version, 1 over root 3. The reciprocal of that is root 3. Okay? And that's your special 30, 60, 90 right triangle. We're supposed to memorize these, by the way. Oh, wait a minute. That's just 30 degrees. Let's use the same construction to find all 6 trig ratios for 60 degrees. That's next. That's just 30 degrees. Okay, so we can do that really quick. Let me give myself a little more room over here. Squeeze it in. So now I'm looking at 60 degrees. So sine of 60 degrees. All right, so 60 degrees is right here. So sine is defined to be opposite over hypotenuse. So I'm looking here. And the side opposite is 4 root 3. So I can write 4 root 3 over the hypotenuse, which is 8. And then this cancels. 4 cancels into 8 twice, or reduces into 8 twice. And I get root 3 over 2. Cosine of 60 degrees is defined to be adjacent over hypotenuse. And so the adjacent side here measures 4 centimeters. So 4 over 8 reduces to 1/2. Tangent of 60 degrees is defined to be opposite over adjacent. So in this case, 4 root 3 over 4 reduces to root 3. And so we might as well, since we did it before, do all those on a calculator to verify. All right. So sine of 60 is root 3 over 2. Very good. Cosine of 60 is 1/2. Very good. Tangent of 60 is root 3. Awesome. Okay. Now, even though we did those on a calculator, we're actually supposed to memorize all 6 trig ratios for these special angles, 30 degrees, 45 degrees, and 60 degrees. Let me finish this off by saying cotangent of 60 degrees is 1 over root 3. secant of 60 degrees is going to be the reciprocal of cosine 2, and cosecant of 60 degrees is going to be 2 over root 3. I'm going to go ahead and leave that unrationalized. All right. And again, we're supposed to memorize these. Okay, great. Now to finish this off, I want to do a couple examples. The first one I have here is to calculate or simplify sine of 60 plus cosine of 45. Now to do that, we're supposed to memorize sine of 60. We just did it. And that ratio came out to be square root of 3 over 2 plus cosine of 45 degrees. We did it. And that came out to be square root of 2 over 2. Now, these two quantities have a common denominator, so I can add across the numerator and put that over the common denominator. And that doesn't simplify any further. That's the exact answer. Now, square root of 3 plus square root of 2, those don't combine. That's not square root of 5 or anything. So that's as far as we can go. Now, from there, we can actually do that on a calculator and get the approximate answer, right? So square root of 3 plus the square root of 2 all over 2. When I hit enter, it gives me the exact, so I got to hit the approximate button. And I get approximately, rounded off to 2 decimal places, 1.57. All right, that's my approximate answer. Now watch the book. Sometimes it wants the exact answer, and it'll say, and sometimes it wants the approximate answer. When you do the approximate answer, you got to use this little wiggly equals, which reads approximately equal to. Okay, so just depending on what the answer or what the book wants, you give either answer. It doesn't matter. Now, certainly you can do this problem totally on the calculator. I can just type that in, and I can actually just get the answer out of my calculator here. Sine of, I'm in degree mode, so sine of 60 plus cosine of 45, and then hit enter. And notice I do get the answer straight out of the calculator. But this one, you know, we weren't supposed to use a calculator. They were just testing us on memorizing that, or memorizing our ratios. So we do need to memorize all 6 trig ratios for 45 degrees, 30 degrees, and 60 degrees, okay? Try not to rely on your calculator too much. Okay, so for the last example, I want to talk about the cofunction theorem. We know sine of 30 degrees is equal to 1/2. We also know that cosine of 30 degrees is equal to square root of 3 over 2. Now, furthermore, we know sine of 60 degrees is root 3 over 2, and cosine of 60 degrees is 1/2. So there's a pattern here. Notice that cosine of 30 and sine of 60, they have the same ratio, root 3 over 2. And also sine of 30 and cosine of 60 have the same ratio, 1/2. So what's the pattern here? It seems like if the angles add up to 90 degrees, which they do here, 30 plus 60 is 90 degrees, the ratios are the same for the cofunctions. And then same here, we have sine and its cofunction, 30 and 60, they add up to 90 degrees. And that's true in general for all cofunctions. And so we get what's called the cofunction theorem. Okay, so the cofunction theorem states that sine of theta is actually equal to its cofunction, cosine of 90 minus theta. Cosine of theta is equal to its cofunction, sine of 90 minus theta. Tangent of theta is equal to its cofunction, cotangent of 90 minus theta. Okay, so with that observation, we can do this last example where they want us to find sine of 28, and that's going to be equal to cosine of what? All right, to solve this problem for the solution here, we would say sine of 28 degrees is actually equal to cosine of 90 degrees minus that 28 degrees. And so 90 minus 28 degrees is 62 degrees. So cosine of 62 degrees is supposed to be equal to sine of 28, right? And notice 28 plus 62, they add up to 90. Now we can actually test that out on a calculator, get it, and see if it's true. So we'll type in sine of 28, and we get 0.4694, right? Or 0.4695. And then we'll also type in cosine of 62. And those two ratios should be the same, and they are. Okay, so the cofunction theorem holds. Very good. All right, with that, we'll see you in the next section.